So hello everyone, this is the 14th video from the DP series. The problem that we are going to solve, that is 2 sets 2. Your task is to count the number of ways numbers from 1 to n can be divided into two sets of equal sum. Right? So you have some n, you have the numbers from 1 to n, you have to divide it into two sets such that the sum of these two sets are equal. So suppose you have n equals to 7, you have number from 1 to 7. So you have to divide it into such that you have to divide into two sets such that their sum are equal. Right? The one of the possible set, that is 1, 3, 4, 6, 2, 5, 7. This sum is 14. This also has the sum of 14. So think about that. What would be the sum? Uh, what would be the sum of set? Right? If you have the n, if you know the n. So what would be the sum? That the total sum that you have is n plus 1 by 2. The set sum would be the total sum by 2. You have to make it equal. Right? The set sum would be 14, 14 always. So you have to uh, divide the numbers from 1 to 7 into set such that their sum would be 14, 14. Right? Now the thing is that if total sum is odd, you are not able to make such you are not able to divide numbers from 1 to n into two sets such that their sum are equal. Right? One set would be one set would have the sum greater by 1. Right? Now let's think about the problem that instead of finding the number of sets that you are able to construct uh, from the numbers 1 to n, such that their sum are equal. Instead of finding that, you have to find how many numbers, how many sets you can construct, uh, uh, how many number of ways you have to find out that how many how many number of ways to construct sum of total sum by 2. How many number using the numbers from 1 to n, from 1 to n. If you are able to find out that the answer would be this, for this answer, right? For this question, that if you are able to find the number of if you find the number of ways to construct sum, that is that set can have, this is what it is, total sum by 2. If you find the number of ways, then this will result to number of ways uh, you can divide 1 to n into two sets such that their sum are equal. This problem, I convert this problem to this problem, right? And this problem we did previously, right? This problem we did it, that how many number of ways to construct the money sum by using the number of ways. This is the similar problem, but there is one problem in this. What it is, that if you find out the number of ways from 1 to n, right, this would result into you are counting double the number of sets. What I mean to say, that if you have a n equals to 4 and you have to count, the sum would be 10, total sum would be 10, and the set sum would be 5. And you have to construct the 5. How many number of ways you can construct the 5 by using these elements, right? These elements. Now you uh, this would result into that you count the number of sets double. That is, there is one possible that way is 1 2. There is another possible way that is 3 2. Right? There is another possible way. Uh, one, there is one possible way that is 3 2, and there is another possible way that is 1 4. Right? Now let's take it to this. Right? So the another set will be 1 4 and 2 3. Right? Another set would be 1 4 and 2 3. This is one of the sets, pair of sets. This is one of the pair of sets. Right? Now, if you count from 1 to n, this would result you count the number of sets twice. Right? Why? The n could be in set 2, n could be in set 1, right? N could be in set 1, right? But you fix the n. If you fix n, that is, if you fix n that n is always in the second set, then you cannot count twice, right? You cannot count twice that you also count set 1, that is 1 4, because 4 is always in the set 2, right? So the another set will be 1 4, and you count it once. If you fix the n, so instead of counting from 1 to n, you can count from 1 to n minus 1 to avoid double counting, to avoid double counting, right? If you fix the element n in the second set, you you can avoid the double counting of sets, right? Now, one question that could arise in your mind, that why you cannot divide it by 2 if you count it double. I cannot do this because I do modulo operations, right? I do modulo operation. You have to print the answer by taking the modulo of by taking the modulo 10 to the power 9 plus 7, right? So you are doing the multiple modulo operation, so you cannot divide it directly by 2. You can find the modulo inverse of 2 with respect to 10 to the power 9 plus 7, then you multiply it with uh, that. So this would result, this would be a little bit intuitive, right? This involves a little bit math, right? This is something that is intuitive. So I hope you understood it. So let's see the code of it, right? I think now you are able to code it by yourself. Still, let's see the code. So let's discuss the code. We take the input n, and then we find the total sum. If the sum is odd, we just print the 0. As we find the set sum, right? This is the set sum, right? We updated the total sum by we divide the total sum by 2. Then we define dp vector, right? We define it with the size of n, right? We have to find the number of ways just from 1 to n minus 1, right? What dp I j represents, I would say dp of I sum would represent. It represents the number of ways to construct some, mm, let's say, some x uh, by using first 1 to I elements, 1 to I numbers, right? So this is something that uh, dpix represent. So to construct the sum 0 by using 0 elements, that is going to be 1. This is our base case. Then we go from 1 to n. Then we try to construct the all possible sum up till 1 to 2, 1 to 3, 1 to 4, 1 to n. Now, if we are not pick, then this is the transition for not pick, that sum remains the same and we are not pick, right? If we are pick, then the sum updated by the remaining sum, right? If we pick I, right, then the remaining sum would be sum minus I. And if the remaining sum is greater than equal to 0, uh, then we are going to do transition, right? What would be the transition? How many number of ways to construct the remaining sum by using first I minus 1 numbers? That is something that you have to add in. How many number of ways to construct sum by using the I, by picking up the I, right? Ith number. So you have to take the modulo. Uh, you have to do modulo, and then we have to print the answer. The answer would be what is the total number of ways to construct the set sum. This is something that is set sum. We are updating the total sum. We divided by 2, so this is set sum. How many number of ways to construct the set sum by using the first n minus 1 elements, right? With the first loop goes from 1 to n, not equal to n, right? So this is the code. What would be the time complexity? The time complexity is n cube. Why n cube? The first loop goes from 1 to n. The second loop goes from 0 to total sum. And and you see that the sum is the order of n square, right? This is something that is order of n square, right? This is n into n plus 1 divided by 4. So n into n, this will be something that is of order of n square. So this would be n into n square, which will be equal to big of n cube, right? So this is the time complexity, and we are using the space of n cross n square. We can say that, right? So space complexity is also going to be n cube, right? So this is the code. I hope you understood it. If it is not, if there is any doubt, comment it down. I try to solve it. Thank you.
Until we reach it, all you need to know is that we're holding